Greetings students, once again welcome to another video from iCampSA. In this video we're going to be doing a past paper questions from a past paper of 2017 grade 10 mathematics, and the area of focus is functions. Let's get into it. Okay, so question 5. The diagram shows the graphs of grx is equal to ax squared plus q, ax squared plus q. That already tells us that we are dealing with a parabola. Okay, plus q. That q, what does it stands for? The q there is our turning point for the parabola, and f at x is equal to mx plus c. That's a straight line. R and s, 2 and 0 are the x-intercepts of G. Remember that R is the mirror image of S. R is the mirror image of X, because a parabola in this format of ax squared plus q is mirrored about the y-axis. So if we were to be asked to find the coordinates of R, it's going to be -2 and 0, because it's just the parabola is mirrored about the y-axis. So the distance from O to R is the same as the distance from O to S. Okay, are the x-intercepts of G, and G is 0 and 8 is the y-intercept of G. If T is 0 and 8, that means that is our turning point, which is the y-intercept, and the value of Q therefore is going to be 8. Okay, graph F passes through R and T. Okay, graph F. So these two functions, they intersect at R and T. Okay, let's go ahead and answer the questions. For 5.1, we are asked to write down the range of G. So as we can see that the function goes from 8 downward to -infinity. So the range of G is going to be y is the element from -infinity to +8, round brackets, because the 8 is not included. Or you could just say y is less or equal to 8. Y is less or equal to 8. Either one is correct. So, and then 5.2, we are write down the x coordinates of R, which we have already determined that it is gonna be -2. So 5.2, the x coordinates of R, is gonna be -2. Okay, calculate the values of A and Q. Okay, Q, we've already determined that it's gonna be what is 8. We can start with that. For 5.3, we are saying Q is equal to 8, and the reasons we can say it's the turning point or y-intercept. So either one is correct. Okay, so what we have to essentially calculate here is the value of A. So what is the equation? grx is equal to ax squared. grx is equal to ax squared plus 8, the value of q. Okay, so by looking at the function that we have been sketched there, it's facing downwards. So we are already expecting the value of A to be what? To be negative. Okay, so in order to find the value of A, we can take any coordinate that lies on this function between R and S. Let's go with S, which is 2 and 0. So where is 0? A is equal to 2 squared plus 8. Let's solve for A. We put 8 on the other side, so -8 is gonna be 4a. We divide by 4 on both sides. Therefore, a is equal to -2. A is equal to -2. which is coherent with the sketch that we have been shown there. Since it's facing downward, the value of a has to be facing downwards. Okay, and then for 5.4 we are asked to determine the equation of f. What do we need in order to determine the equation of f? The straight line is to calculate the gradient, and to calculate the gradient we need two coordinates. We already have two coordinates, which is r and t, and we also need to calculate the value of c, which is the y-intercept. So c is essentially going to be 8 since it's the y-intercept. Okay, so for 5.4, let's start by writing down the coordinates that we have is r, which is -2 and 0. Quickly double check, yes, and t, which is 0 and 8. T, which is 0 and 8. Start by calculating the gradient, value of m, difference of the heights over difference of the run, y1 minus y2 over x1 minus x2. This is gonna be equal to 8. Let's take t as our y1. 8 minus 0 over 0 minus 2. 8 divided by 2 is gonna be 4. 8 divided by 2 is gonna be 4. That is our gradient. And therefore c, since it's the y-intercept, c is equal to 8. And we can put the reason here is the y-intercept, where x is equal to 0. So it's already calculated for us. There is no need to calculate it again. So c is equal to 8. Therefore, the equation now becomes, what is this called? It's f. So the equation is going to be f at x is equal to 4x plus 8. 4x plus 8. That is going to be the equation of f. Okay, and then from there, let's go to 5.5. 5.5. Use the graphs to determine the values of x for which f at x is equal to g at x, where these two functions are equal. So it's going to be here where they intersect. It's where x is equal to -2 and where x is equal to 0. So for 5.5.1, where the two functions are equal. So 5.5.1, it's where x is equal to -2 and x is equal to 0. Those are the two points or x values where the functions will be equal, and then use the graphs to determine the values of x for which x multiplied by g at x is the parabola, is gonna be less or equal to 0. Okay, so where the function of g at x is gonna be less or negative, because yes, where it is less than 0, the function is essentially negative. Okay, so where x multiplied by g at x, so if we divide by x on both sides, so we're essentially looking for the values of x where the function of g, the parabola, is gonna be less or equal to 0 essentially. And then we have to use the graphs to determine that, but I will guess it's where x is less or equal to r, or x is greater or equal to rs. Yeah, where the function is less or equal to 0, where the function is less or equal to 0. So this is 5.2. So is the values where the function of g at x is negatives from r going down here, and then from s going down there. Okay, but where x multiplied by g at x is negative, where x multiplied by g at x is negative, so when we multiply the negative values of x with the negative values of x with the positive values of f at x, there on that interval, we're gonna get negative outcome. For this situation here, we're gonna get a negative outcome. But once we get here, positive values of x, we multiply with the positive values of positive, essentially right up until here, with the positive values of g at x, we're gonna get a positive outcome. So it's essentially the intervals from here, from negative infinity to r, and also from r to 0, and then we jump, and then we have s, and then from s going forward, from the coordinate s going forward, we just have to put that in weights. Okay, I hope you do understand. We do understand what we are dealing with here. So for 5.5.2 it's gonna be where so the first interval is gonna be where x oh wait a minute, where x multiply, no, I think I made a mistake here, from r, x multiplied by g, the negative values, we have negative values, this continues, essentially negative values, we have negative values of x multiplied by negative values of g at x. We're gonna get a positive outcome. So that part doesn't work. So it's essentially this interval between r and o, and the interval where x is greater than 2. So let's start with the simple one. Where x is greater or equal to 2, the positive 2, where we have x, and then where x, the other interval, is between negative 2 and 0. So it's greater than negative 2, but it's greater or equal to negative 2, but less or equal to 0. So those are the two intervals where we're gonna have x multiplied by g at x less or equal to 0. Okay, and then for 5.6, the graph of h is obtained when g is reflected along the line y is equal to 0. What is the equation of g? G is we haven't calculated the equation of g. Okay, write down so it's only just reflected about the y is equal to, about the x-axis, about the x-axis. Okay, where y is equal to 0. Yes, because y is equal to 0 here. Okay, write down the equation of h in the form of, okay, so we are reflecting the function of what? Of g. Let's quickly write down the equation of g. G at x, we know that q is 8 the equation of g at x is negative 2x squared plus 8 is negative 2x squared plus 8. So, and we have to reflect this equation about y is equal to 0, and that is 5.6. 5.6. For 5.6, we are told that h at x is essentially a negative g at x, is a negative g at x. Therefore, h at x is going to be equal to negative, what is g at x is negative 2x squared plus 8, negative 2x squared plus 8. Therefore, h at x is going to be negative, multiplied by negative is going to be a positive 2x squared minus 8. That is the function of h. If we were to be asked to sketch this function, it's essentially going to come out like in this form. It's going to be in that form there, you know. And the turning point of the function is going to be 0 and it's going to be 0 and negative 8. Okay, but then we're not asked to do that for 5.6. I think it marks the end of question 5. Let's go ahead and do question number 6. Okay, the function p at x is equal to k is equal to k to the power of x plus q is described by the following properties. Excuse me. So k is greater than 0, but k is not equal to 1. Okay, yes, k cannot be equal to 1, because if k was 1, it doesn't matter to what value we raise 1, we always gonna get the same answer. So it's just gonna be a horizontal line. Okay, so the horizontal asymptote, or the x-intercept at 2 and 0, and the horizontal asymptote is at what? Is at y is equal to negative 9. Y is equal to negative 9. Okay, y is equal to 9. What is the horizontal asymptote from the equation? It's q. So that is going to be negative 9. And then, yes, okay, for now, I think let's just work with what we're given. For 6.1.1, we're asked to write down the range of p, that equation. So if we know that the horizontal asymptote is negative 9, therefore what is going to be the range of p? So the function starts from negative 9, right above negative 9, going upwards, you know, because we are dealing with the y values. So for the range 6.1.1, we can say y is greater than negative 9, or the other alternative, y is the element of negative 9 not included to positive infinity. Okay, determine the equation of p. We already have the what you call this thing, the value of q, which is the asymptote, it is negative 9. We can find the value of k, which is the unknown. That would be 6.1.2. 6.1.2. P at x is equal to k to the power of x plus q, and then p at x is equal to k to the power of x. What is the value of q? Is negative 9, and we have the coordinates, which is the x-intercept at 2 and 0. 2 and 0, so 0 is equal to k to the power of 2 minus 9. We take the 9 to the other side, k squared is equal to 9, and then we introduce a square root on both sides. Therefore, the value of k is equal to 3. of which will now make the equation of p to be p at x is equal to 3 to the power of x minus 9. P to the power of x, 3 to the power of x minus 9. Okay, that is 6.1.2. Next, sketch the graph of p. Clearly show the intercept with the axis and the asymptote. Okay, the intercept with the axis and the asymptote. We already given the x-intercept, so we just need to calculate the y-intercept and then we sketch the function. So 6.1.3, before we sketch y-intercepts, let x equal to 0. So y is equal to 3 to the power of 0 minus 9. 3 to the power of 0 is going to be 1 minus 9. Therefore, y is equal to negative 8. That is the y-intercept of the function. And therefore, once we are here, we can sketch. We're going to use the intervals of 2 because we are dealing with big numbers here. So we're going to have 2, 4, 1, 2, 3, 4, 2, 3, 4. Okay, so we're going to have negative 2, negative 4, negative 6, negative 8. Okay. Negative 8, negative 10. Okay, then we have 1. Let's use 1, 2, 3, 4, 2, 4, 6, 8, 10, negative 2, negative 3, negative 4, negative 5. Okay, let's sketch the function. It starts with the asymptote, which is negative 9. Negative 9. Yes, the asymptote is negative 9, so it's right between negative 8 and 10. So it's gonna be here where y is equal to negative 9, and then we have two intercepts, which is at 0 and 0 and negative 8, the y-intercept, and then the x-intercept is at what? X-intercept is at 2 and 0. So it's gonna be here 2 and 0. Once we have that, we can go ahead and sketch our function. It's gonna be of that nature. And that is how our function is gonna look. The intercept is 0 and negative 8, and we have 2 and 0, 2 and 0. Okay, and this function is the function of p, which is p at x is equal to 3 to the power of x minus 9. And that is how your function is gonna look. Okay, that was 6.1.3. Okay, next for 6.2, the sketch below shows the graphs of f at x is equal to k over x plus w. F at x is equal to k over x plus w. We are seeing an x in the denominator, which tells us we are dealing with a hyperbola plus w, and that w is a what? Is the horizontal asymptote for a parabola, and g at x is equal to negative x minus 1. The graph G is an axis of symmetry of what? Of f. So remember that the axis of symmetry cuts at what? At the asymptote. There, the y-axis here. Sorry, the y-intercept of the axis of symmetry is the same as the asymptote. So the value of w, if we were to be asked to find the value of w, is gonna be what? Y is equal to -1 because of the information we've been given about the axis of symmetry. The graphs of F and G intersect at P and Q. If we are asked to find the values or the coordinates of P and Q, what do? We simply equate the two equations because the graphs are equal or they share those coordinates. Okay, so that is that. Let's go ahead and answer the questions that follows. 6.2.1, write down the value of W. What is the W? What does the W variable represent on our equation? It is the asymptote. So W is going to be equal to -1 for 6.2.1. For 6.2.1, W is equal to -1. Okay. 6.2.2, the point -2 and 7 lies on F. Calculate the value of K. So just this is a hint that we have to use these coordinates. We already have the value of W, which is -1. We can calculate K. So this is 6.2.2. 6.2.2. 6.2.2. What do we have here? F at x is equal to K over x plus W. F at x is equal to K over x plus W. Okay, we have the coordinates. What is the coordinates? -2 and 7. -2 and 7. We have to substitute that. So we can have 7 is equal to K over -2 minus 1, the value of W. So let's solve for K. -1 on the other side, we're going to have 7 plus 1 is going to be 8. It's going to be 8 is equal to K over -2 multiplied by negative on both sides. Therefore, K is equal to -16. -16. Of which we now this make the equation of F to be F at x is equal to -16 over x minus 1. But here we only asked to find the value of K. Calculate the x coordinates of P and Q. Where the functions intersect, they intersect at P and Q. So G and F are both equal. So we just have to equate the two equations. So let me start by writing that down for 6.2.3. 6.2.3 at P and Q, F at x is equal to G at x. So we can use that information. That is where they intersect. F at x is equal to -16 over x minus 1 is equal to -x minus 1. That is the equation of G. Equation of G, -x plus 1. Just double checking. Okay, now let's solve for x once we are here. -1 and -1 on both sides, so they will cancel. We essentially gonna have -16 over x is equal to -x multiplied by negative on both sides. -x, we're gonna have x squared is equal to 16. Okay, we have to introduce a square root here. A square root, x squared is equal to 16. And when we introduce a square root, we have a positive and a negative root. Positive and a negative root. So therefore, x is equal to -4, or x is equal to 4. X is equal to 4. And here we are asked to find what? The coordinates of P and Q. So we have to find the corresponding y values. We can just use the function of G for that. So G at -4 is gonna be -4 minus 1. So g at negative 4 is going to be negative 4 multiplied by negative is 4 minus 1 is going to be 3. And then let's find g at 4. G at 4 is going to be negative 4 minus 1. Negative 4 minus 1 is going to be negative 5. G at 4 is going to be minus 5. So we have negative 4 and 3, and then we have 4 and negative 5. Let's see which one goes with which one. So P is at a negative x values but positive y values, while Q is at a positive, it's to the left of the y-axis, so it's at a positive x values and a negative y value. Therefore P goes with what? Negative x, so it's negative 4. So we're gonna see P is negative 4 and 3, and then Q goes with a positive 4 and negative 5. And that is how you go about finding the coordinates of P and Q. Remember that whenever you ask to find the coordinate where two functions intersect, it doesn't matter whether it's parabola and the hyperbola, or it's exponential and a straight line. Where the function is intersect, they are always equal. Just equate the two functions and you solve for x, and then you find the corresponding y values. Okay, next, write down the values of x for which negative 16 over x is greater than negative x, negative 16 over x. What is negative 16 over x? Negative 16 over x, let's come here. Let's come here. It's which function? 6.2.2. Remember that negative 16 over x is essentially the function, the hyperbola, the function, yes, the hyperbolic function, but with the asymptote of what? Of 0 instead of what? Instead of negative 1. Negative 16 over x is this same function, but now it has been shifted because nothing was added. It just has what you call this thing, it just has an asymptote at 0, and we are also find the values of x for which that function is greater than negative x, okay, it's greater than negative x squared. Okay, no, I think for this one it would be just simple if we do it values of x, yeah, if we just solve for x the way that we do in inequalities, because graphically it's sort of difficult to represent. So for 6.2, for 2.4, yeah, let's just solve for the values of x that will justify that inequality. Yeah, that will justify that inequality. That would be the simplest way to go about the 6.2.4. I was trying to solve it using the graph, but I see that this is just an inequality equation. 6.2.4, we have negative 16 over x greater than negative x. Let's solve for the inequality. X minus multiplied by x multiplied by x on both sides. We're gonna have negative 16 minus x squared minus x squared. We divide by a negative on both sides. The sign is going to change. We're going to have 16 is less than x squared. 16 is less than x squared. Okay, and then what do? We introduce a square root. To find the critical values. Let's do like this: x squared, introduce a square root on both sides. So we have a negative and a positive square root. So we're gonna have x is greater than 4 positive square root, or x, remember when we introduce a negative square root, the sign has to change. So x will be now less than negative. X will be, wait a minute, first thing first, x is greater than negative 4. Let's do like that first. Or x is greater than 4. Okay, x will be greater than 4, or x will be less than negative 4, or x will be less than negative 4. No, x will be greater than, x will be greater than 4. Essentially, this will be negative 4 less than x. Okay, let's see. Yeah, I think it's gonna be those values of x, where x is greater than 4, x is greater than 4. Okay, and where x is greater than, negative 4. Let's see, negative 5 squared will give us what? Will give us 25, which will be greater than 16. Which will be greater than 16. Which will be greater than 16. 3 squared, x will be greater than 4. Negative 3 squared, gonna be 9. Yeah. Okay, let's see. X will be, where x is greater than 4. Okay, I'm trying to see, because I see when we get to 0 here, 0 squared will be just 0. It's not gonna be greater than 16. Okay. I think I see what happens here. A negative 4. So introduce a negative square root on both sides. Yeah, let's just go with this one answer. Let's just go with this, where x is greater than 4. This will validate the inequality. This will validate the inequality. Yeah, okay. That is question 6.2.4. And until we meet again, I wish you good luck and good studying.